Hi, I'm Scott Bass with Edmund Optics here for another episode of Light Talk, where we break down industry trends with some of the best in the business. And special edition today, we are here at SPIE Photonics West in San Francisco at the Edmund Optics booth, and we're going to talk to some of our own experts about some of the demos and products we have in the booth. Let's go take a look. So I'm here with Ian Schwartz, our product line engineer at Edmund Optics. How are you today, Ian?
I'm doing great. How about you?
Good. You having fun at the show?
Absolutely.
All right. So tell me about some trends you're seeing out there. You're talking to customers a lot.
Absolutely. So there's a lot of demand right now for fused silica substrates on a lot of our products, especially our high reflective mirrors.
So explain to me, what is that? What does that mean?
So fused silica is a really great substrate, especially because of its great thermal properties and high durability.
Okay, interesting. So I'm assuming this demo somehow explains this concept?
Sure, it absolutely does.
Walk us through this, please.
Sure. So over in this box right here, we have one of our fused silica substrate mirrors with a high reflective coating on the front of it. We have one mirror reflecting off of one laser reflecting off of this mirror, and then one of our wireless Bluetooth power meters measuring the reflection off of this mirror. Now, fused silica, while it is a terrific substrate, unfortunately is totally transparent in the visible range. And as you can see on the front of this box right here, the little bit that's going through this high reflective coating is transmitting straight through the mirror and leaving a red spot on the back here. Now this is pretty dangerous for laser safety reasons and also can really be detrimental to high sensitivity applications. Now in the box on the right here, we've come up with a solution to an issue like this. Using a doped variant of fused silica, we've created our Schwartz mirrors. Now this is jet black in appearance throughout the entire material, meaning that it's highly absorptive, especially in that visible range where fused silica doesn't quite shine. And on this outside of the box, you can see the effects firsthand. There's no red dot on the outside. Any throughput that goes through that high reflective coating is absorbed by the mirror substrate itself, increasing laser safety, removing the need for beam blocks or beam dumps, and still having that same performance as regular fused silica mirrors.
Fascinating. Thanks so much for walking us through the demo. Enjoy the rest of the show.
My pleasure. Thanks.
I am here with Jay Cotton-Martin, Vision Solutions Engineer for Edmund Optics. How are you?
I'm doing great. How are you, Scott?
Good. How's the show for you?
Show's been great. A lot of opportunity to see really cool stuff in the industry, photonics, talk to people you haven't seen in a while. So it's been a really good opportunity to get.
So what's going on in the world of imaging?
Well, in imaging, there's been a demand for higher and higher resolution. It's talking higher bandwidth, sensors in the cameras, different interfaces, and the need to see smaller details with more pixels.
Okay, and how does this demo?
Sure, so we're showing off today a more conventional high-resolution lens designed for a 1.1-inch sensor, right? So you're talking 12 megapixels, 20 megapixels, 24 megapixels. And here we have another 25mm lens, just like this one, running at the same f number, f2.8, so you get high resolution. But this one has an integrated liquid lens, all right, from one of our partners, Optical. And basically what we're showing here is that with the conventional lens, you have a single plane of focus here that's very sharp, really high contrast. But you won't be able to adjust that position, right? What does that mean? So if you have different elevations, targeted object areas, right, you would need to manually refocus this or have some sort of motorized focus. Here, you can change that focus position with just the liquid lens element. Okay, and as you'll see here, we're actually sweeping through focus all the way from Paris to Tokyo to San Francisco. All right, you can program this with different time of flight or distance sensors. And you can also set up different sensors to gauge position, right? You trip a certain number of sensors, you go to a lookup table that you program with the liquid lens, and it focuses to the correct position. So this really opens up opportunities for high resolution imaging at different working distances with millisecond time response.
Great. Thanks, Jay. And I love the use of the Legos, by the way.
Everyone loves Legos.
Were they hard to build?
Yeah, a little bit time consuming, but not the worst thing to do.
I see that. Well, enjoy the rest of the show. Thanks again.
Thanks, Scott. You too.
So I'm here with Pat Sasso, product line engineer for Laser Optics. How are you, Pat?
Fantastic.
How's the show going for you?
I think it's going really well.
Good. So tell me, what's new in the world of laser optics? What are some trends you're seeing out there?
Yeah, so lots of customers using higher power laser systems, using shorter pulse durations in the ultra-fast spaces, and moving more towards the UV so that they can process smaller features.
Okay, so tell me a little about this demo.
Yeah, our demo here is highlighting our laser crystal manufacturing capabilities. First, we start out by sourcing raw material from a raw material supplier. We can slice, core, grind, polish, and coat all the different laser crystals that we advertise on our website. And we do a number of different quality control steps as we manufacture those parts. In the end, what you end up with is a finished laser crystal product, something that might look a little bit like this.
Great. All right, well, thanks, Pat. I appreciate you walking us through the demo. Enjoy the rest of the show.
Thank you.
Okay, I'm here with Christina Kazai, Product Support Engineer with Edmund Optics. How are you, Christina?
Doing well.
How you
Happy
doing?
to be here.
Great. You enjoying the show so far?
Definitely am. It's my first trade show, but it's gone very well so far.
Great. So there's a lot of variety of products here. What's going on?
Yeah, so we're kind of showcasing our benchtop system. We have a coherent laser shooting into a 90-degree mirror mount here. It's being expanded by a laser beam expander, and it's being sent to our Scanner Max Galvo, which is what is creating all of this cool imagery in the background here. You can't see it with your bare eye, but these mirrors in here are actually moving very fast, which is what is sending the signal through. We also have a Optics F theta lens here, and if you move it out of the way, you will actually see the focus change. So it's actually focusing and it's evening out all of the laser lines that you're seeing on that screen there. And we also have our E-Series kinematic mounts on display. This here is just going to showcase all of the capabilities that we have for mounting on optical tables as well.
Great. Thank you so much for walking us through this. Enjoy the rest of the show.
Thank you. You guys too.
So there you have it. I hope you enjoyed seeing some of the demos coming to you live from Photonics West 2022. I hope you enjoyed this episode of Light Talk, and we'll see you next time.